Today we are going to discuss about the MOS device physics. A MOSFET is a four-terminal device with the terminals being source, drain, bulk and a gate. A MOSFET has two heavily doped N regions and a heavily doped polysilicon layer which is placed over silicon dioxide. The poly forms the gate terminal, while the heavily doped N regions form the source and drain. You may wonder, why do we call it source and drain when the MOS structure is symmetrical? That is because the source is a terminal that can be thought as the terminal that provides charge carriers, while we can consider drain as the terminal that collects the charge carriers. So in case of an NMOS, the source is the one that is at a lower potential, while the drain is the one that is at the higher potential. We also make sure the bulk is either grounded or the bulk is connected to the source so that they are reverse biased. This prevents body effect, which tends to alter the threshold voltage of the system. We'll discuss about these terminologies in later videos. Now let's discuss about the actual functioning of a MOSFET. When the gate voltage is 0, there is no current flow in the system. However, there is still a depletion region that gets formed due to the PN junction. As the gate voltage increases, for an NMOS, the gate is a positive voltage. So the holes repel and the minority charge carriers forms a depletion region under the gate voltage. When the gate voltage reaches a particular point, and at a particular point, an actual channel forms between the source and the drain, and this channel is called as the inversion layer because it is formed by the minority charge carriers. And now if the voltage between the source and the drain is greater than the overdrive voltage, an actual current flow occurs. An overdrive voltage. Let's discuss what that is. Overdrive voltage is basically the excess gate to source voltage above the threshold voltage that is required in order to turn on a transistor. Here I have drawn the characteristics, the voltage current characteristic of a MOS. The main region of operation that you kind of need to know in a MOS is the linear region, which is also called as the ohmic region, where the MOS represents the characteristics of a resistor. As you can see here, the voltage current characteristics is the same of a resistor. While the drain source voltage becomes higher than the overdrive voltage, the MOS enters a saturation region. This is a region in which most of the amplifiers are operated in. The interesting characteristic here is, for a particular gate to source voltage, you can see that the drain current remains almost constant in the saturation region.